Welcome to Raw Perfect classes. In this class, I will continue propositional logic. Now, in this video, I will discuss about rules of inference. Rules of inference. Rules of inference are logical tools which are used to derive for conclusions from premises, or you can say premises. Rules of inference are logical tools used to derive conclusions from premises, and they form the foundation of logical reasoning. They allow us to build arguments, prove theorems, and to solve problems in mathematics, computer science, and philosophy. To understand these rules, we should be construct valid arguments and ensure that conclusions follow the logically from given informations. Rules of inference are essential tools which are used in logic and mathematics and which are used to enable the derivation of conclusions from premises. And they also form the backbone of logical reasoning. Backbone of logical reasoning. And proof techniques. And proof techniques. And they are extensively used in fields like computer science, engineering, mathematics. Now, first, which is basic rule of inference, that is modus ponens. Modus ponens. This is a law of detachment. Law of detachment. If condition statement is true and its if part is true, means if then part is true and its if part is true, then its consequent part is true. If then part true, if part true, then part also true. Means, for example, you have given if P implies Q and P, then result will be Q. P implies Q, P and result will be Q. This part is true, this part is true, result definitely will be true. For example, you have given first premise P1, if it rains then ground will be wet. Ground will be wet means if it rains, that is P, then ground will be wet is implies Q. Premise 2, it is raining. It is raining. It represent to P. Conclusion, the ground is wet. That is represent to Q. How to solve? P implies Q means not P over Q. P and result will be Q. How? P cut with not P and you will find result Q. This is modus ponens. Second one is modus tollens. This is law of contrapositive. Law of contrapositive. If, then, true. If is false, then is false. Means if P implies Q and not Q, then result will be not P. How? P implies Q can be solved by not P or Q. Not Q, not Q. Result will be not P. How? This one cut with this one and you will find not P. Example P1. If it rains, the ground will wet. P2. Ground is not wet. Ground is not wet. Conclusion, it is not raining. Not raining. So that's why this is modus tollens. P implies Q, not Q. Result will be not P. Next rule of inference is hypothetical syllogism. Hypothetical syllogism. If two condition statements are true, means if P implies Q and Q implies R, then P implies R. If two condition statements are true, where consequent of first is antecedent of second, then a third conditional statement combining antecedent of the first and consequent of second is also true. Means P implies Q, Q implies R, result will be P implies R. How? Not P or Q, not Q or R, result will be not P or R, and you can say P implies R. Example, P1, if it rains, ground will be wet. Ground will be wet. Second premise, if the ground is wet, the plants will grow. The plants will grow, and result will be, conclusion is, if it rains, the plants will grow. Will grow. P implies Q, Q implies R, and P implies R is the conclusion. Now next inference of a rule of inferences. Disjunctive syllogism. Disjunctive syllogism. If a disjunctions or statement is true, one of the disjuncts, the part of the or statement is false, then other disjunct part must be true. Means if P or if P or Q and not P, then Q. P or Q, not P, then Q. This one cut with this one and we find Q. For example, premise 1, it is either raining or sunny. Premise 2, it is not raining, not raining. Conclusion, it is sunny. Means P or Q, not P and Q. Now next is a conjunction. If P and Q, then Q and Q. If two statements are true, then their conjunction is also true. P and Q means P and Q. Premise 1 is it is raining Premise 2 is it is windy. And conclusion is it is raining and windy. This is P, this is Q, and this is P and Q. And next point is simplification. Simplification. If P and Q, then P. If P and Q, then Q. Example, premise 1. It is raining. It is raining and windy. Conclusion, it is raining. Now next is addition. If P, then P or Q. Example, P1, it is raining. Conclusion, it is raining or sunny. For all x, P of x, that is known as universal instantiation. P of C for an arbitrary C, universal generalization. There exists x, P of x, existential instantiation. Existential instantiation. P of C for some C. Existential generalization. For example, we have given P implies Q and R implies S. Not Q or not Q or not S that is equal to not P or not R. We have to prove it. This is a destructive dilemma. First, P implies Q, that is equal to not P or Q. R implies S, that is equal not R or S. Now solve it. Not P or Q and not R or S, not Q or not S. Or Q, this Q, cut S with not S, we will find not P or not R. Now next, second question we have given constructive dilemma. P implies Q and R implies S and P or R, and result is Q or S. How to solve? Not P or Q and not R or S, P or R, you will find. This will cut with this and we will find Q or S. Now next, resolution. P or Q, not P or R, we will find Q or R. This is the answer. Now next question, related to conjunction P and Q. Conjunction means P and Q. Now next question, P and Q and result will be P. This is a simplification. Now addition, P, in addition we will write P or Q. Disjunctive syllogism, P or Q, not Q, not P, and result will be Q. Finished. Next, hypothetical syllogism. P implies Q, Q implies R, P implies R is the result. This one cut and then you will find P implies R. Modus tollens. P implies Q, not Q. This will cut with this one and not P is the answer. Modus ponens. P implies Q and P and result will be Q. In this video, I have taught you how to use rules of inference. Thank you. If you like this video, please like and share my channel with your friends so that they can take benefits from upcoming videos. Thank you.